Hello, everyone. Apologies for being slightly behind schedule. We were actually just on the other side of this in the waiting room talking about this topic. So looking forward to today's presentation. I know there's a lot of enthusiasm, a lot of interest from across the country in attending this webinar. So we appreciate everybody being here today. My name is Ken Lancastle. I'm the Chief Operating Officer with MCA Canada. And I am very pleased to be introducing today's webinar brought to you by Mitsubishi Electric Heating and Cooling. As always, we'd like to recognize and thank Mitsubishi for their expertise, for lending their expertise, and for helping to share thought leadership with MCAC members, as well as the industry at large. So today we're going to hear about a very important and very topical issue for the industry, the transition to A2L refrigerants and the changes to the CSA mechanical refrigeration code. These changes are transforming how systems are designed, installed, and maintained across Canada, and are going to have an impact on all stakeholders across the HVAC supply chain. Now, before I introduce our speaker today, I just want to note that we will have some time for Q&A at the end of today's presentation. I would encourage you to use the question and answer function that's built into Teams, and we'll be monitoring that throughout today's webinar and presentation. So with that, I'm very pleased to introduce our speaker today, Pushpinder Rana, the Director of Products and Services for Mitsubishi Electric. As a professional engineer, Pushpinder has more than 25 years of experience in the HVAC industry, and he's one of the leading subject matter experts on the A2L transition in Canada. So we're very fortunate to have his expertise today. Pushpinder is going to share some of the changes and considerations for our industry and how industry stakeholders can stay compliant in this transition. So without further delay, I'd like to turn things over to you, Pushpinder. Thank you.
Thank you, Ken. I hope I'm audible. So big pleasure to be here again doing this seminar. A big thanks to MCAC for taking the lead to organize this seminar. It's not something new. We never heard about it. I think these topics complement each other very strongly. The A2L transition, which has become a hot topic for our industry, especially in North America, and CSA B52, the mechanical code, which we released in 2023, December precisely. So these topics heavily complement each other. Things are evolving, and we truly understand the anxiety or the curiosity of the unknowns, and it's a continued learning process. We'll try to touch some key aspects of these two sides of our HVAC lives. I would encourage questions at the end if we have time. Otherwise, you know what, leave your questions and we'll try to get back. I will also share some of the contact details, which is a more formal mechanism to get clarifications on CSA B52. So there's a big working committee which is working behind the scene to keep our code updated. I sit as a chair on B52, but we'll get into more details. So once again, a warm welcome to everyone. And thanks to MCAC for organizing this key session. And hopefully we'll have some good learning and updates for everyone. And you know what, we'll try to learn and apply into our routine work life dealing with A2L refrigerants. Let me share my screen. Okay, I just need a clue if my screen is visible to everyone.
It is, yep.
Okay, good. So warm welcome to everyone and very good afternoon. As Ken introduced, my name is Pushpinder Rana. I work as the Director of Products and Services with Mitsubishi Electric Sales Canada Inc. I hold, well, that's my qualification. I don't want to speak too much about it. I sit as a chair on CSA B52. And I'm also working very closely with some of ASHRAE, technical committees or working groups, precisely SGPC 41 and TC 8.7. They are primarily into heat pumps and VRF technologies. So that's part of my work life, industry engagement, dealing with code standards and regulatory affairs across North America. So today, Uh, well, I assume a lot of almost everyone is aware of the evolution, how we have moved with time from CFC and HFCs. Uh, I'm sure a lot of us, back in the days dealt with R11, 12, 13. R12 was very famous refrigerant, commonly used. 11, 111, 112, 113. So those were CFC refrigerants. The problem was the ODP from the get-go. We moved from CFC refrigerants to HCFCs. We got into R22 or 406A, as I remember. So that's the evolution, moving from CFC to HCFC refrigerants. Uh, GWP was not a concern, perhaps in those days, and the finding was, these refrigerants are impacting ozone layer, so we need to address the ozone depletion. And you would know, Montreal Protocol, which kicked in, and there was a global effort to mitigate, ozone depletion, and that's how HFCs like R410A came into existence. So we resolved, high ozone depletion issue, and it ran for many years, at least since I joined the HVAC world. I dealt with R22 and then 407C and R410A precisely. So then there was another finding, what, we have resolved ODP issue, but now we are causing another issue, the global warming. No wonder we see, all the natural calamities, environmental issues here and there, and it's very much caused by greenhouses. So you would know how the global warming works. The greenhouses, they trap the green gases, they trap sun energy into our atmosphere. So we are trapping the heat, which is melting, glaciers, and that causes, the rising sea level and all the changes in our environment. So that's another issue, global warming impact, which opened another big chapter, how we deal with ODP and GWP altogether. So then we move to the next phase, which is a call for zero ODP and low GWP refrigerant, and that's how A2Ls came into play. So A2L, we heard a lot about, the flammability, this and that, and we're gonna dive deeper into it. But the it's not that A2Ls were not around; they were part of, blends. So nothing is very new. Of course, we mitigated ODP and GWP concerns, but now we are dealing with flammability. To me personally, I think it's overhyped terminology, flammability concerns, but there are some nice measures in place. So a lot of testing and a lot of research has gone into developing A2L refrigerants, and now we know that HVAC equipment with A2Ls are already in the market. More in the North America, Canada is starting. So it's not that equipment is not here. We know A2L equipment is now available in Canada. Uh, so there's a political, work behind all these ambitious targets and all that. Canada has a global commitment. We are part of the Kigali Agreement, so it's done at the federal level. So and then there's a top-down approach. So we are part of the Kigali Agreement. Precisely, Canada is part of, Group 5, Article 1, which includes other countries as well, and we ratified Kigali Amendment, which is our global commitment to reduce HFC impact and the consumption. So this is just a bit of background, how things are, starting right at the federal level or at the government level. And once these things are set, then the targets are set, which are time bound. If you see here, this is Canada's HFC consumption phase down schedule for a given year, and at a global level, we are looking at HFC consumption cut down by almost 80% in the next 30 years. So that will avoid, more than 80 billion metric ton of CO2 equivalent emission. You can imagine the amount of energy or heat which we are trying to manage via all these ambitious targets, and that would avoid up to 5 Celsius warming of Earth atmosphere by the end of the century. Now, zero point 0.5 Celsius may look very little if you're dealing with HVAC, but at the environmental level, it's a lot of heat to manage. And we have a lot of evidence, how things are changing in our environment. So we are on a very, very ambitious goal. So there's a criteria how the phase down or the baseline is set. So you see here 2019, 24, 29, 34, 36. So we follow a baseline. And that baseline is typically the average consumption of HFC from 2011 to 13. We take that and adding 15% of Canada's HCFC consumption to create the baseline for given years. So this is what we all are working towards, and I can assure you that refrigerants are not the main culprit that behind all this change in our lives. Of course, we have a very ambitious HFC reduction, targets set by government, but we are not the main culprit. If you're dealing with refrigerant, there are far more other, participants or items which are contributing and working to attain all these environmental goals. I'm not seeing any questions, but I do hear if there are questions coming in the chat box, but maybe we can deal with that at the end. Sorry. Okay. Just a second. Now we'll get into a bit, scientific finding. Again, I'm not sure. I'm very sure you have seen this information. So precisely, standard 34, ASHRAE standard 34, it does the job of classification of refrigerant into different classes in terms of toxicity and flammability. So R410A is a beautiful refrigerant, A1, so low toxicity and low flammability or no flammability. But the problem with R410A is obviously high GWP. So precisely it's 2088. And when we are dealing with GWP concerns, so R410A is definitely refrigerant with very, very high GWP. And that became the target refrigerant to be addressed. So now in terms of the classification, if you see here, 2L is a class we are dealing with. So there are many refrigerant types now already available in the market. But in terms of properties, 3 key parameters: the LFL, lower flammability limit, HOC, which is heat of combustion, and the burning velocity, which is the last or 4th parameter. So any refrigerant which has heat of combustion less than 19,000 kilojoule per kilogram, and burning velocity, which is the maximum velocity at which a flame would propagate if there's a fire, then it has to be less than 10 centimeter per second. So this is a typical classification to put a refrigerant under A2L class. And we have many examples like R32, 454B or 454C and many more. And they all must meet the 2L class requirement to be A2L. And we are dealing with lower flammability, which is a big topic for the industry. So I just mentioned about R410A, which is our current refrigerant, R32 and R454B are most commonly used A2L refrigerant, as we are hearing from the industry. But if you look here carefully, look at the GWP. So I just said R410A has a GWP of 2088, and that's where we are paying our attention to resolve such high GWP limits. And if you compare R410A with R32 is 675 precisely, 454B is 466, 454C is like 475. So there are many refrigerant which would fall under A2L category, and all have burning velocity less than 10 centimeter per second. So they qualify as A2L. So for R32, it's 6.7. 454B has a lower burning velocity. So, but there are a lot of, anxieties or guesswork or concerns, like how serious really is this flammability? And it's not that R32 is something new to the world. R32 is part of R410A. It's already in there because R410 is a blend and R32 would be a single fluid. So it's not that, R32 is something very new to the world. We've been dealing with, flammable refrigerant for decades. Propane, hydrocarbon runs in every household in Canada when use your furnace. So flammability, personally, in my opinion, is overhyped. If I were to, introduce A2L, I would more talk about low GWP refrigerant rather than, focusing on flammability. Is the way, it sets your perception. So let's take A2L as a low GWP refrigerant, and if there are any flammability concerns, then the onus is on manufacturers and installation practices to follow the codes and standards, and it's all set. So as long as equipment is manufactured as per UL standard, everything should be fine. So flammability is a topic, but I don't see it's such a concern. But the benefit is we are addressing the GWP. So for 454B, it has almost 68.9% R32. So R32 is not new, or 454B is not really a flammability concern. So some details are given. If you see here, A2L would require much greater energy to ignite. So that's where your LFL or lower flammability limit would come into play. Uh, Many potential, ignition sources will not ignite any A2L refrigerant. And similarly, your common household items, whether it's a microwave or toaster, it will not ignite A2L refrigerant. And when I'm talking about it, we are already dealing with propane, to run our furnaces, which is definitely inside the house and running for many, many years in Canada. I'm My message here is if we can successfully deal with propane in our houses or our residences or other application, A2L is far, far easier to deal with. Okay, this is where I want to make sure that the audience understands where Canada and US are aligned. So let me make it very clear. We don't have a precise regulatory alignment between US and Canada. So you may be aware of fact sheet by the US. It's set by EPA for the AIM Act. Their fact sheet have tons of details. Every equipment type, the compliance date, the import restriction date, and the targeted GWP. Relatively on our side, the only table we know is ODISHAR Schedule 1.1, which is under ECCC. The only table which still exists and the only equipment which is covered in our regulation would be chiller. We do not have any regulation for room air conditioning system or VRF systems or heat pumps. Why I'm saying this, we hear lots of rumors that R410A is illegal in Canada, we cannot sell it. We are not following US regulation. In the US, yes, as of 31st December last year, you can't import, or you couldn't import R410A heat pumps less than 65,000 BTU, correct? And this year would be VRF system. Uh, but that's the US regulation, guys. I want to make sure that you hear me loud and clear. The only regulation in Canada as of today is only chiller. So if you're dealing with R410A heat pump or VRF system, there are no established dates, no regulations in place, no import restrictions. So if you're dealing with R410A heat pumps and VRF system, life is as usual. So just be very clear, our regulation or our alignment with the US is not exactly as expected. They are ahead. Our regulation is only about chiller, so which was 2025, uh, and including a GWP limit of I think 750. So just be very clear, if you're dealing with comfort industry, there is no restriction on R410 heat pump or R410 VRF system. Life is as usual. Because I hear a lot, we hear from what's happening in the US and then there's no clarity. Canadian regulations do not comply with US regulation. There is no alignment which is done yet. There might be some work in place, but by the time, this is my personal opinion, by the time it happens, I think we'll be already done with R410A equipment. But still, as a regulation, there is no regulation to ban the importation or any sell-through restriction or any installation restriction on R410A heat pumps and VRF system. Please make sure you're very clear of it. If you're dealing with R410 equipment, there's no change for Canada. Okay, that was a little bit about our A2L transition timeline. Things are still evolving. We are working very closely with HRAI, ECCC, our federal entities. There are some efforts to have at least some alignment with the US, but it's a work in progress, and it's a very detailed process. There's a public consultation process, and then amendment, then review. It takes time. So US is definitely ahead of us, and we are not following US in terms of, any transition timelines or import restriction. I just want to make sure that it's very clear and we are not misled by rumors or we hear from here and there. B52, which is our next topic now. So most of us would know that CSA B52 released their new mechanical code precisely December 22nd, I believe 2023, and this code provides all the guidelines we would need to deal with A2L refrigerant, whether you are equipment manufacturer or you're a consulting engineer or you're a contractor. So this code provides you, a lot of information to deal with A2L refrigerant, and there are other changes as well. I will not be able to, give all the details because we have limited time, but code is there. Grab your copy. Go into all the details, but we'll touch on some of the key changes just to help you. And if there are questions, I'll provide you the contact details. If there are any questions or RFIs or RFCs to be submitted, there's a process in place by CSA B52 or CSA precisely. So we'll quickly, go through some of the key changes which have been added to CSA B5223. And guys, before I go any further, if you also deal with ASHRAE standard 15 and 34 precisely, their speed of amendment is much faster than the Canadian side. If you would know, CSA B52 was based on 2022 version of ASHRAE standard 15 and 34. So we are still on 23 version for B52, but already ASHRAE has released 2024 version of standard 15 and 34. So looks like they are making amendments, adding addenda to their codes much more frequently than CSA can do. So our revision cycle is longer than ASHRAE standards, and you would need both. So this is a big message from my side. Code is okay, but CSA B52 code still has some limitations. So my big message here is you would still need to refer to latest version of ASHRAE standard 15 and 34. And I will give you some examples at the later part of my presentation. But let's go through, our code very quickly. Now, if you remember, until 2018, we had an exclusion in B52. So air conditioning in private residences were not included to comply with B52. So that exclusion is removed. So and all the provinces have already adopted CSA B52, as I know from HRAI. So air conditioning in private residences exclusion is removed. So they are now supposed to follow the code, whatever clauses are applicable. Clause 3, if you have a copy of CSA B52, by the way, we recently released a handbook. so which can be helpful to you, but I'm talking about full code. So there are many new definitions which were added to CSA B5223 version or 13th edition precisely. Now, again, I'm going to repeat my message. A lot of contents are taken from ASHRAE standards because um, uh, you know there were some limitations though, copyright issues or intellectual rights. So whatever we could take from ASHRAE standards, we have added, or B52 committee could add to the new edition. But there is still a lot of information that you would need to take from ASHRAE standard, especially 15, if not 34. But I'm just giving you a quick view of some of the new definitions. EDVC, which is your effective disperser volume charge. A quick definition. Uh, this is the maximum charge or discharge which is permitted in the event of any leakage. So your code tells you if should any leakage happens, which I hope will never happen, but should it happen, then EDVC calculation tells you what is the maximum allowable discharge in the event of leakage. And in no case you can exceed that limit. So there is a calculation criteria which I will explain in the coming slide. But just to give you an example, RCL definition is there. LFL, we didn't deal much with LFL. RCL, was the criteria to make sure you don't exceed the limit based on smallest space volume if you're using, a connected system. But now LFL is playing a bigger role to make all the calculations. And LFL is refrigerant type dependent. For R32, LFL is 19.1, as I remember. R454B has a lower LFL value, and R454C has a different LFL value. So depending upon the refrigerant type in question, the calculation result will be different because you're dealing with different LFL values as per the refrigerant type. So a lot of VRF equipment, as we know, would be mostly R32. So one discipline to follow. But mini VRF or even large capacity residential HVAC equipment may have R32 or 454B. So according to refrigerant type, guys, the calculation result will be different because of LFL. Uh, Clause 4, which is very important. So it talks about system selection and application requirement, again taken from standard 54. I'm going to repeat my statement that everyone is strongly encouraged to have a copy of standard 15 and 34, not 22 version, but 2024, which is the latest version. And there are changes. There are clear differences between our current edition of CSA B52, Standard 15 and 34 2022, and Standard 15 and 34 2024 version. I have some examples to show you why it's important that you follow always the latest ASHRAE standard. There are clear differences and they have their own impact. Clause 4.5 talks about A2L for human comfort. So if you're dealing with, heat pumps or VRF equipment for human comfort application, which is anyways the primary market for heat pumps and VRF system, this is a very, very important clause. It talks about, all the calculation, EDVC, as I said, MREL, which is the releasable charge, and especially figure 7A and 7B. So if you see here, this is a very, very critical table. Or in simple terms, this is the compliance path. So depending upon your equipment type, the amount of refrigerant it carries, and the installation location, it helps you to determine, do you comply or not? And if you don't, what are the options? And within the compliance path, it guides you to refer to relevant clauses so that every time you know how to make sure you don't break the rule. Some calculations are pretty simple, straightforward, but for if you're dealing with larger quantities or depending upon the location, as I said, you may need to have a different criteria or different strategies to make sure your system is complying with the code. A very simple example is if you look at the top, I know it's not easy to read, but you would see in the code. So if your equipment has less than 6.6 pound of refrigerant or 3 kg, and it's not installed in a public corridor or a lobby, you just comply. So small capacity, residential HVAC system carrying less than 3 kg of refrigerant and not installed in a public corridor or a lobby, they just comply as long as they follow, manufacturer guideline. But for larger systems, you're dealing with kgs of refrigerant, and depending upon the installation location, depending upon the occupancy type. I mean, institutional occupancies, they have a different requirement. I'm sure most of you would be aware of it. So this flow chart is a good guiding tool to it holds your hand to make sure that you're complying. And if you're not complying, then what options do you have? So these flow charts are also taken from ASHRAE standards. It tells you how to calculate EDVC and which clause or addendums to follow at the end of the code, so that you have precise understanding of all the formulas and the parameters to make the calculations. Okay, this clause is very critical. I'll have more details in the coming slides, but it tells you about the manufacturer's obligations. If you would know that a lot of equipment would come with built-in detection and mitigation, control logics. But this clause tells you in what condition there is a obligation on the manufacturer. So the system comes with built-in, mitigation and detection, but it's not needed in every case either, guys. So as per the clause, if your system carries less than 4 pound or 1.8 kg of refrigerant, you just comply, because we are dealing with, little quantities, and they will not exceed the flammability or LFL concerns in most of cases. But should you exceed this limit, there's a different path to follow. So as I said, for if refrigerant systems, now depending upon the installation location and the occupancy type, the criterias are different. So I gave example of institutional application, old age care, prison, police station. There are so many occupancy types which would fall under institutional application. They have a slightly different criteria. So be very careful when you're doing calculation for as per the location and the occupancy type, you follow the correct formula to make EDVC calculation. Refrigerant quality shouldn't be your concern. Everybody must be using virgin refrigerant, and it's typically manufacturer provided, or you need to do trim charge or additional charge, so your contractor is going to take care of it. But there are guidelines on the quality and purity. Just like ASHRAE standard 15, B52 also, it doesn't recognize ammonia as a refrigerant under standard or a code, which is a key change. So IIAR2 should be followed. Prime mover rating has increased from 125 to 500 kilowatt for A1 and A2L refrigerant. If you remember, it was only 125, but this is to comply with design, construction, and testing as per B51. For most of heat pumps, because I come from heat pump and VRF industry, so I might be a little bit more leaning towards that equipment type. So as long as you follow UL 60335-2-40, you're covered. You're well covered, and these are the standards anyways most of manufacturers need to follow, AHRI and the UL standard. So that would cover your design, construction, and testing. But the prime mover rating has been increased from 125 to 500 kilowatt. Clause 6 deals with A2L refrigerant to be used in the mechanical room, 7 for overpressure protection. So there are, it's a guiding tool to let the content of a given clause and if it's relevant to you or not. Annexes are very critical, and this is where you find all the relevant details. So clauses can give you, a certain level of information, but then you would need to refer to all the annexes at the end to dive deeper. Some annexes are informative, not mandatory. Some are normative, which are mandatory. So I'm not going to spend too much time on this one. You have annex. So we have a long list of annexes at the end of the code from A to Q. and every NX has a relevant meaning and the content which you can use. So some of the informative annexes are explained here. Um, Again, some are normative, some are informative. Okay, this is where we can spend some time. So all the highlighted ones, in my opinion, are more relevant in your day-to-day life. So these annexes can provide you more relevant information. Now, I'll have some examples at the end, to support my statement, but there are clear differences between B52 and ASHRAE standards. So I will repeat again, you need to have both in your hand, because if any information is missing or is not fully provided in B52, then we can take that information from ASHRAE standards 15 and 34. So that's a statement I have mentioned in here. And some of the examples I have taken, I'll show you to save time. NXN, which is very critical. So this NXN gives you all the information how you do EDVC calculation. So you would know from the standard, ventilation has a big role in terms of our system design. So if there's a ventilation provision, whether it is, triggered by your sensors or leakage detection mechanism, or it's continuous ventilation, which is running all the time, the formula is different. But if you don't have a ventilation mechanism or provision in place, then the formula is different. When you do your EDVC calculation, I will show you. So I really, really hope everybody would be, aware of the ventilation way, and do the EDVC calculation. If you don't, then the path is different and it may become more restrictive. So NXN deals with your EDVC calculation, a very, very important tool. NXO deals with releasable refrigerant charge. So guys, if you remember, I said at the very beginning, we are dealing with maximum allowable, which is EDVC, and then potentially releasable, which is your MREL. So there are two factors, and we would need to compare at the end. Again, EDVC is what's maximum allowed in the event of any leakage. You can't exceed that limit. And MREL, which is releasable charge, tells you how much can be released in the event of any leakage. So it's not a very straight definition because there are so many, equipment in play, your refrigerant detection system, the response time, the mitigation system kicking in. There are many factors which will decide what's the releasable refrigerant charge at the end, and are you within the limit, are you under EDVC, or you're exceeding. If your releasable charge exceeds EDVC, you don't comply, period. NXP gives you some details, as I said, where manufacturers have the obligation to provide a built-in detection system. So it can be your sensors, it can be your alarm, it can be your push notification. I will give some details because there are restrictions how the detection system and mitigation system would play. It's time bound, it's time sensitive, and we have to make sure things are working as they should within given time limits. NXQ talks about the ventilation requirement again for high probability system. So when we talk about high probability system, just for your knowledge, heat pumps, dehumidifier, they all fall under high probability equipment category. So human comfort, as I said at the very beginning, can be replaced with a high probability system. And this is what ASHRAE has done in their revised version. I'll show you very quickly. Okay, but this is where things get pretty interesting. So we talked about EDVC, how you calculate. But if you see here carefully, everyone, there are two ways to calculate EDVC. One, if you have a ventilation mechanism which is integrated, or it could be separate, but still it's there within your building, within your premises, then there's a different path. But if you don't have the ventilation system in place, for example, then you follow the gravity equation. So the first one is your air circulation is triggered by your your refrigerant leakage detectors, or there is always a continuous air circulation to maintain your, let's say, indoor air quality. So if you have ventilation system as per A and B in place, then you follow the first formula 7-8. But if you do not do that, then the formula is different, and more details can be seen in the code or standard, because there is a lot to calculate, your VF, which is your space volume, LFL, conversion factor, and FOCC is as per your, occupancy type. For institutional, it limits by half. I've been repeating again and again, all these calculations are also driven by your occupancy type. So if you deal with institutional occupancy, FOCC has a different value than all other occupancy type. So those details can be found in the standard or the code. And the lower formula is when you don't use ventilation system, then you follow a different path. Ventilation, so this is like a transfer area opening. So you can connect space to form a larger space. So this is a way we can have a permanent opening, so that the connected space gets added to your addressable space. So this clause tells you how to calculate the opening size. There's also a criteria about the positioning of this opening. It's not that you can just put it anywhere. No. So there's a way, I think it's like 12-inch above the floor level, but again, go back and make sure. So there's a way to calculate the opening size and the location. Only then you're permitted to include the connected space into your EDVC or MREL calculation. So use it as much as you can. Then you're dealing with larger space volume, just to comply with any limitation in terms of EDVC and MREL. So one more time, this is a formula how you calculate the opening size, and there is a clear guideline on the location of the natural ventilation opening. We talked about manufacturer provided detection mechanism. I just included some drawings in here. Now there are many types of indoor units. You have wall type, you have ducted, you have non-ducted, you have floor standing, you have multi-position. So in almost in every case, your indoor unit will have a built-in leakage sensor. On a case-by-case basis, sometimes it can be factory provided. I mean, it's built into the equipment, or it can be field applied. So the onus is on the manufacturer to provide, but not every equipment would need to have a leakage sensor. For example, if you're complying with code, for example, if you remember, you are less than 6.6 pound and you're not installing in a lobby or public corridor, everything is fine. You don't need anything. But should you go, deal with higher quantities, or depending on space volume, you need to have a detection which is working. So again, equipment would have built-in sensor. And in most of cases, guys, you're not doing anything. There's a built-in algorithm, control logic, and all the hardware which comes manufacturer provided in most of cases. We need to make sure our calculations are correct. That's the bigger onus on design engineer or a contractor. Equipment is manufactured as per UL standard or the codes. So it tells you that if your equipment has more than 1.8 kg or 4 pound of the refrigerant. So that's one example where a sensor has to be installed, either installed in the field if it's loose provided, or it could be built in. So check with your manufacturer on a case-by-case basis. Either it's built in or it should be installed in the field. Similarly, there will be more layers. You'll see on the labels, A2L with a flame symbol. It just tells you so that you can understand that this equipment carries a mildly flammable refrigerant. So symbol is on the label, outdoor unit, indoor unit, and there will be more references or layers in the overall scheme. So you may have thermostat with audible alarms to send you alert if there's any leakage that would happen. You would see error codes in the event of leakage. There might be built-in procedures like auto shutdown or auto pump down, where system will automatically do the pump down, and it's going to send you notification alerting the contractor or the owner in the event of any leakage. So now this is where things might be slightly different between manufacturers. I strongly urge you confirm with the manufacturer in question that what kind of provisions do they have in their equipment to mitigate or to address any leakage concerns should any leakage happen, because things might be different from manufacturer A to B. Okay, guys, this is very critical, maybe more applicable to our contractors or contractor community. Some of the limitations, how detection and mitigation has to work. So I especially included this slide just to make sure that you have a good idea of, and it is time bound. I've been repeatedly saying it's not that, it can work when it wants. No, there's a time bound criteria or limitation set by the standard. Field calibration of detection is not allowed. Whatever is needed by the code, you just need to comply with it. Uh, there are many sensors. R410A has a different sensor. So you need to make sure that if there is anything you're applying in the field, then it is matching with the refrigerant type. Uh, Self-diagnostic has to be working. So this is where equipment design comes into play, but that needs to be checked that it's working or not. And in the event, if self-diagnosis check fails, it should automatically energize ventilation, because system is going to assume there might be some leakage. Standard is set on worst case scenario. To be realistic, there can be many scenarios where there is actually no leakage, still there was a detection. So there can be those scenarios where system has detected a leakage for many other reasons while there was no actual leakage, because standard works on the worst case scenario. So there could be scenarios of false detection. It's very much possible. So similarly, system, is doing self-diagnosis, checking from time to time if my detection mechanism is working, it's responding, and if it won't, it's a alert for the system to run the air circulation, and generate the output signal within 30 seconds. If detection is exposed to 25% of given LFL. So I said that LFL is different for R32, different for R454B. But if sensor senses a leakage of 25% of LFL, it should generate the output signal to to start the mitigation arrangement, whatever you have, within 30 seconds. So there are more needs under the detection. I'm just taking a few selective ones. There are more to it. So please, you can check the code for more requirements. On the mitigation side, again, as soon as the signal is here, the output signal is here, it should generate the mitigation response or signal within 15 seconds. Within 50 seconds of receiving the output signal, mitigation system should kick in within 50 seconds. That there can be many strategies, energize the air circulation fan for the ventilation, de-energize duct heaters if you are using any, or activate the mechanical ventilation or SSOV. Now, almost in every case, especially if you're dealing with VRF or commercial heat pumps, there will be a safety shutoff valve. It will be manufacturer provided, and each manufacturer may have their own strategy how these SSOVs will work. Check with them for details, but SSOVs are very much part of, mitigation measures. Now, mitigation measure should run for at least 5 minutes after the output signal has reset. So let's say your detection system finds that the LFL is under 25% of LFL. So that's the baseline. After that, whether it is the air circulation or whatever you're doing, it should run for at least 5 additional minutes. Now, SSOVs can be resettable, or they would need a manual, a reset. So depending upon the type of SSOV you're using, if it's automatically resettable, there are additional guidelines. So please make sure you're aware of the additional guidelines in the event if SSOV is resettable. But if it needs a manual intervention, somebody has to go and reset, then that's a different path to follow. Uh, Okay, I'll very quickly talk about some of the differences between ASHRAE standards and B52. There are clear differences and there are valid reasons, copyright issues or intellectual property, this and that. But one big change which ASHRAE has done, CSA B52 still talks about human comfort. So the clause says A2L for human comfort. ASHRAE standard version 24 has changed the definition from human comfort to high probability system. That's a big change. It doesn't change the clause content or the formula, but the definition has changed from human comfort to high probability air conditioner, heat pumps, and dehumidifier. So that's a change. On the ASHRAE side, B52 is still 23 version, so we still have retained the human comfort. This is a big example. So I said, I've been saying again and again, if you see here, when you do EDVC calculation, if you have the ventilation in place, there's a different path. But if you don't do ventilation, you follow gravity equation, then you need to refer to this table to get the MDEF value. But the main message here is on my left side, B52 couldn't take all the tables from ASHRAE, again, because of same issue, copyright, intellectual property. So this is a prime example why you would still need to take missing information or anything which is not covered in B52, you would need to take it from standard 15 or 34. So this is one example. There can be more example, but if you deal with EDVC calculation, which doesn't have air circulation, and you need to deal with gravity equation, the table are taken from ASHRAE standard, but we couldn't take all tables or table in full. So this is one example. It is only for reference. You would still need to take it from ASHRAE standard. That's another example. LFL conversion factor, which is needed for EDVC calculation, which I said at the very beginning. If you compare, if you're using ASHRAE standard 22, the LFL values are different from what standard 24 has taken. And we are looking at 454B, 454B, and C. So just be mindful to always use the latest standard of ASHRAE standard 15 or 34. This is just another example that LFL values are different. And if you use a wrong value, your end calculation will be different. Maybe it's not applicable to contractors because you're not doing the front end calculation. It's more applicable to consulting engineers or design engineers who are working on system design and application. But it's just an example how things are different between CSA B52 and ASHRAE standards. This is very critical. It's a challenge for CSA B52 to follow the pace of revision as ASHRAE standards would do. ASHRAE standards have done their second revision in 2 years. So they are very quick. Maybe they have better resources, more dedicated resources. That's not, unfortunately, the story with B52. B52 has more volunteers who are, working or supporting our codes and standards. So as a chair, I'm trying to minimize the cycle from 5 year to 4 year at least. I hope we can make it to 3 year, but it's a very, very challenging work. What we want, a greater public participation. So I have given the email ID of our project manager. We want greater public participation. So if you are reading the code, if you're aware of any, if you have any issues in terms of interpretation or correction, this is the link how you can make a submission to CSA. Make your submission, give them suggestion, and participate if you can, so that we can quickly look into our next revision. Again, B52 is working very hard to reduce our revision cycle from current 5 year to 4 year. We cannot do as fast as ASHRAE for sure, but at least CSA B52 tells you to refer to latest ASHRAE standard 15 to support. But in terms of our own cycle, we are trying for a 4 year cycle now. So this is the email ID. Send your questions, make your submissions. There's a form which gives you the authority as a public to make your submissions to CSA B52, and maybe it will help us to quickly work on our next version, which can be 2028, but we want it to be 2027. So we are almost towards the end of this seminar. So I use this slide in my, typical public participation or industry participation, that it used to be one thing, but I have added one more. So to be successful on this path, a deep understanding of B52 and ASHRAE standard 15 and 34 is very critical. Nobody can teach you, all the changes, clauses, formulas in these sessions. There has to be a self effort and it needs time. So I urge everyone, get a copy of, standards and codes, spend time on it. You should have questions, challenges to understand. I have provided you the email ID. You can make your submission, and CSAB 52 will absolutely help to make sure you understand system application installation and service needs. And please attend trainings provided by HRAI or manufacturers or trade union. A2L is a new learning for everyone. We don't have all the answers either. And I have shown you many examples how things are different between US and Canada, not in terms of regulatory alignment, but also in terms of code standards and all that. So it's very important that you understand how things are different and what's applicable in Canada. So we greatly expect a lot of training opportunities that will be provided by trade unions or CSA and HRAI. Please make sure you avail every opportunity, attend the training. Learning takes time. There are many changes. And I'll give you one quick example. I still have a copy in my hand, if I can find it. Okay. I don't know if you can see, even ASHRAE standards are evolving. I'll give you a very quick example. If you're dealing with R410A, VRF system, there was a RCL criteria. Should you install, VRF system at a place like Denver or Calgary? There is an altitude adjustment, sea level, and as you go high. We don't have those details yet in ASHRAE standard 15, 34, or CSAB 52. So there is a new addendum called Addendum K. That addendum, and we are part of it, which is a good news. So that addendum K is precisely addressing altitude adjustment. If you want to put, HVAC system at high altitude places like Calgary, Edmonton, then we don't have those guidelines. So even standards are evolving, but we can only work with what's available. So make sure, guys, you keep an eye on, all these amendments, updates, addendums getting released, and apply. And if you have any question, please consult CSAB 52, and we'll try to help as much as we can from the public side or from the regulatory side. So that was all about my presentation. I hope it was helpful. Learning, sorry, learning is a journey. Spend some time on codes and standard. Please read, try to understand. And if you have any question, then I have provided the email ID to send your queries, and we'll try to address with a formal process in place.
Well, thanks very
Thank
much
you. I think
for spending.
Ken.
There are a few questions that have popped up throughout your presentation. I know some of them were answered, but it might be good just to revisit them as well. So I'm just going to go sequentially in terms of what came first. The first question was, why did Mitsubishi Electric select R454B for smaller units and R32 for the VRF unit?
Good question, by the way, and why we face this question, guys. R454B is more suitable for small capacity system. Number one, it has a lower GWP than R32, as you would know. So if you are a really environmental champion, then you have another option. R32 is very common. Almost everyone is using it. R32 technically is more suitable if you're dealing with larger quantities or larger pipe runs. Then R32 is more suitable. 454B is better for smaller capacities, residential application. And on top, I can't speak against R32 because R32 is also being offered by Mitsubishi. But technically, and also a product strategy, 454B is more suitable. Also, it has a lower GWP, but that would go against R32, so I can't use that as a reason. But that's more, it's a better choice for small capacity, smaller quantities. R32 is more suitable for bigger systems like VRF, especially if you're dealing with long pipe runs.
Another question here. Any final notification on when R410A would be banned for import in
No,
Canada? No.
I deal with this question. So I'm heading for our CSA annual general meeting in Niagara Fall starting. So I'm sure there will be lots of discussion on this, but just for everybody's knowledge, we are working very closely with HRAI and ECCC. It's a lengthy process. My personal opinion is by the time our federal side will really put any amendment or any ruling in place, R410A will be kind of already absorbed if you still have that stock. So in my honest opinion, it may take a year or even more than a year. There is some work which has very recently started, but it's a very, very slow process. I don't expect it's going to happen even next year. That's my honest opinion. So don't expect any regulatory alignment in terms of R410A banning happening anytime soon. It's a very, very lengthy process. There's a bureaucracy. There are multiple public consultation, and then there is a formal review process, easily more than a year, or it could be longer.
Next question here. Should an A2L refrigerant line set run in special line set casings? And the follow-up, will there be any building code change?
Building code, I'm not privy to the building code sign, but line sets are your normal copper piping, so it doesn't need any change in terms of the installation material and all that. The only change would be SSOV. So depending upon the equipment type, you would need to install safety shutoff valve sometimes within the line set, depending upon the location and the equipment type. In certain cases, it would be built into your branch controller, for example. But in terms of line set, these are typical copper piping. So there is no special refrigerant pipeline that would need to be used. But yes, if you're dealing with, if should you need to install safety shutoff valve or branch controller in between, that's where manufacturers should train you what you need and how to do it.
How do VRF systems using A2L
Mhm.
avoid exceeding EDVZ limits in concealed areas where the refrigerant piping may be run?
So I gave a quick example. With RCL, you were it was based on the smallest space. In the worst case, all refrigerant would, enter that smallest space, and you can't exceed the RCL limit. That was easy. With EDVC calculation, as we know from the standard and code, you would need to calculate for every space being served, and you have to make sure your MREL, which is your releasable charge, never exceeds EDVC. And if it happens, you have strategies like natural area, natural ventilation. You could connect these spaces to get a bigger, larger space in the event of any leakage. So there are some strategies in place, but the rule, the rule of thumb is never exceed MREL over EDVC. So you would need to calculate both, and there is a way to calculate MREL. MREL calculation is manufacturer specific because it needs to calculate, the volume of refrigerant your fan coil is carrying, which may be different from brand A to brand B, and the refrigerant between your safety shutoff valve and to the evaporator coil. So there is a way how to calculate MREL, and it is manufacturer provided database.
I know you talked about this previously, but are there any instances where B52 is more stringent than ASHRAE 15 or conflicting
No,
information between the two?
no, no, no. The only caution I want to give is more changes are happening. There are maybe 20 or 29 addenda under ASHRAE standard 15. So it's a challenge for B52 to keep our code updated with ASHRAE standards. So what we are doing, we have included a guideline. Should you find any pending information or missing information, just refer to ASHA standard 15 and 34. But in my opinion, B52 is not more stringent than 15 and 34. Almost every content is taken from ASHRAE standards for the most part.
Question here, ASHRAE 15 is asking for air circulation. Can we get your interpretation on this? Is it a requirement on outdoor air or fresh air that needs to be admitted, or is it simply referring to the mixing of
No,
internal air to avoid pocket of higher
correct.
concentration?
Air circulation means you're making sure that if there's any leakage, you are throwing it outside your living premises. It's not tied to fresh air as such. It is tied to making sure the leaked refrigerant leaves your premises. So it's the ventilation.
What precautions should be taken when connecting to an auxiliary heater, when connecting an auxiliary heater to an A2L refrigerant indoor unit?
Good question. So UL has defined the maximum surface temperature of your electric heater. I think it's around 700 Celsius. I don't remember precisely. So basic control measure would be, if your system detects the leakage, it should immediately energize your duct heater or any heaters which is connected with the system. But if they are running independently, that's a different case. I'm talking about system integrated auxiliary heating, which can be used for backup or emergency or maybe supplemental. But as per code, it should immediately de-energize your heaters.
When can we expect a B5223 update to reflect ASHRAE 15? Addendum A.
2027 December as of now. If we get help from public, then otherwise it's 2028. I had to apologize because I don't work for CSA either, but as a chair, we all are volunteers. It's a lot of work to match with how quickly ASHRAE standards are getting updated. But currently our target is 2027, which is shortening our typical 5-year cycle to 4-year. It's still an ambitious target. I hope it can work, but that's the timeline we have currently.
I believe that is it for the questions that we've been given so far, Pushpinder. So on behalf of MCA Canada, I want to thank you again for your expertise on this topic. This was a very well attended webinar, and there's a lot of people who've stayed online throughout the questions as well. We will be posting a copy of the recording onto our YouTube page. So for anybody who'd like to come back and revisit this, that will be made available to you. And as well, I would encourage you to follow up with Pushpinder if you have any questions further to this presentation. So again,
do you mind if I make one last statement? Because
absolutely.
This question really disturbs me. I think I see the pain point. I get this email about R410A and all that. My last statement to be loud and clear. There is no restriction, no trouble if you're dealing with R410A heat pumps or VRF system. There is no regulation, guys. Don't get misled by if you hear these rumors from US story is different from Canada. We are okay with A2L. We are okay with R410A as of now.
Great. Well, again, I'll leave that as the last word. And again, thank you, Pushpinder, for your time, expertise, and thank you to Mitsubishi Electric Heating and Cooling.
Thank you, guys. Have a good day.
Have a great day.
Thank you so much, everyone.